Okay, so this is the part of the lesson anyways for Unit 9, Objective 1, and that is on exponential functions and graphs. So mostly we're just going to kind of give a little introduction to what is an exponential function, and then how do we graph according to parent graphs, which should be a review from our Algebra 2, but we probably have forgotten quite a bit of it. So we have two different types of exponential functions that we'll be working with. One is what we would call exponential growth, which is an increasing function, or exponential decay, which is a decreasing function. And so when we have something written as y equals a to the x, a is what we refer to as our base, so a is our base, and then x is our exponent. And then that result, y value, is our value, so the base raised to the exponent, and the y would be the resultant value. And then we had some restrictions on what a could equal in order for it to be considered an exponential function. And we did this again, a little bit last year. So we had where a had to be greater than 1. And so if we had, 1.5 to the x or 2 to the x, then that would be an exponential growth function. And it's considered increasing because as x is increasing, so is our y value, so we're going up. And so as x increases, y increases. And then this over here, so a is still our base, and x, in this case negative x, is our exponent. And so if we had 2 to the negative x, that could be also rewritten as 1 over a to the power of x. And the same restriction here, a has to be greater than 1. So if we had 1/2 or 1/3, then we're multiplying a fraction by itself as many times as whatever x would be. And so if we do, like, say, 1/2 times 1/2 times 1/2, our numbers are getting smaller, and therefore we would have a decreasing function. Where over here, if a is greater than 1, so say 2, we would be multiplying by 2 over and over again, so 2 times 2 times 2, which would give us larger values, again, which is why we would have an increasing function. And so the domain for both of these graphs is all real numbers, or negative infinity to infinity, because we can evaluate, this equation for any number of x, whether it's 1 or -5. While our range, however, we have a horizontal asymptote at y equals 0. So there's our horizontal asymptote. And so then there's no graph down here, so our range would be from bottom to top. We start at 0 and then go to infinity. And so therefore our range would be from 0 to infinity, not including 0, but up to 0. And the reason we don't get any negative values is if we have all our bases have to be greater than 1, so these are always positive. Exponents don't turn things negative. They either make them larger or make them smaller based on if we have a positive or a negative power. And so again, a power does not turn something negative. It just multiplies it by itself over and over again. And then our y-intercepts for our parent functions are at 1, and then of course there's no x-intercept on our parent graph because we have that horizontal asymptote. So what you're going to have to do for homework is you're going to have to graph. So I just have two examples here where we have to graph the function. We have to identify any asymptotes or intercepts, and then state whether or not the graph is increasing or decreasing. So for the first equation, we want to identify increasing or decreasing, and that way we have kind of the basic shape of what we're working with. And so I look here and I have a positive x, so because I have a positive x, then that means my graph is going to be increasing. And that gives me a sense of what my graph is going to look like. So I know that when I graph it, it should look something like that. It's just kind of a little mini version of what we had above. And then I want to identify the shift, and this is exactly like what we did in the last unit. I need to look to see, okay, what's affecting my x, what's affecting my y. And so if I look up here, I'm subtracting 2, so this is x minus 2. And so that means I'm shifting on the horizontal, and that would be for 2 units. And so I would be going right 2. And now if there had been like a plus 1 down here, then I would have to go up 1. Or say minus 3, then I would go down 3. And then I'm not multiplying by anything here, so then there's no stretch or reflection. And so once I kind of get a general sense of what's going to happen, I still want to create a table, and with that table I want to always use at least 3 values. And so I'm just going to create an XY table here. And I really can use any numbers I want for X, but usually my numbers can get really large quickly because it's exponential, or really small, and then that makes it tough to graph. So I always like to start around where my shift is, horizontal shift, which is at 2, so I always want to start near the horizontal shift, and I usually make that my middle number, and then I pick one number smaller and then one number bigger. So whatever my horizontal shift is, that's where I start, and I make that in the middle, and then one number smaller, one number bigger. And then all I have to do is replace X with 1. And so I'll have 2 to the 1 minus 2, which is negative 1, and that's just the same as 1/2 or 0.5. And then replace X with 2. And so 2 minus 2 is 0, so 2 to the 0 is 1. And then one more, replace X with 3. 3 minus 2 is 1, 2 to the first is just 2. And then once I get to here, I'm just going to plot those points. And so I'm just going to make an XY graph, or coordinate axes. Okay, and so plot my points. So I have to go over 1, up 1/2, and then over 2, up 1, and then over 3, up 2. And again, I know the graph, the basic shape is like that. And then because I only went left or right, my horizontal asymptote, which I know is normally the x-axis, if I slide that right 2 units, it doesn't go anywhere, it's still a horizontal asymptote. So I still have a horizontal asymptote, and I have to identify it, so I'm going to mark it as horizontal asymptote at y equals 0. And then for my graph, I'm going to do that. Trying not to cross my horizontal asymptote. Okay, and so then there's my horizontal asymptote. So I did that part of the directions. I have my graph, so that part's done. And then my intercepts, I have no x-intercepts. And I would only have an x-intercept if I have a vertical shift. And then for my y-intercept, I want to let x equals 0 to find my y-intercept. And if it was a parent graph, I would know the y-intercept is at 0, 1. So I'm going to let x equal 0. So I go to my equation. So I have y equals 2, and then replace x with 0. And so that's 2 to the negative 2, or 1 over 2 squared, which is 1/4. So there's my x-intercept. I have none. And then my y-intercept would be when x is 0, my y is 1/4, or 0.25, right? Same thing. And then the other thing that we had to do in the directions was identify if it's increasing or decreasing, and I did that part right here. So I know that I have an increasing function. And then that's the basics of it. Okay, so that's kind of a simple one, nothing too complicated there. So now let's take a look at this next one. Okay, so this next one, there's quite a bit here that's a little bit tricky. So increasing, decreasing, that sort of thing. And then I have E, and so we studied E last year, but just as a reminder, E is like pi, it's just an irrational number, but it is about 2.718, okay? All right, so now if I look at this, I have negative 3e to the negative x. So when I take a look at that graph, I kind of have two things I have to take into account. First of all, where's the E button on my calculator? And that should be somewhere near your log button. And if you can't find it, then just use 2.718. Okay. So the other thing I have to take a look at is that I have a negative x here. And so that negative x implies that we have a decreasing function, right? We have a decreasing function. But I'm also reflected. So although the parent graph is decreasing, this negative means that it's going to flip over the x-axis, which is now going to become, because it's reflected, it will become increasing. So it's kind of like a double negative is what's happening there. And so for my shift, I have a +1, so that means I'm going to go up 1. There's no value up here for the x, but then I also know I'm reflected along the x-axis because I have that negative, right? Whenever we have a negative value, that flips my graph over, okay? All right, so I want to create a table. So I have no horizontal shift, right? And so I always want to create near the horizontal shift. So no horizontal shift means 0. And then one number smaller and one number larger. And so I'm going to replace -1 for x. So I'll have -3e, and that'll be a double negative, so that'll be 1 and then +1. And so again, if I don't know where e is on my calculator, if I can't find that, then I'll just use the 2.718. And so when I type that in, I'll get -7.2. Okay, replace x with 0, so -3 e to the 0, and then +1. And then e to the 0 is just 1. And so then -3 plus 1 is -2. And then plug in 1 for x, so, oops, that's a 1 there. So I'll have -3e to the -1 plus 1, which is real close to 0, so -0.1. Okay, now I'm going to graph it. And then I have to go at least down to -7 because of that y value. So I'm going to have to extend my y here. So I have to go over -1 down to -7.2, over 0 down to 2, and then over 1 and almost to -0.1. Okay, so now for my horizontal asymptote, normally it would be at y equals 0 according to the parent function, but then I went up 1, so I need to move my horizontal asymptote up 1. And so then graph it. So I have my horizontal asymptote at y equals 1. I found my y-intercept, which was nice because I let x equal 0 already. So my y-intercept would be when x is 0, y was -2. And then for my x-intercept, and this one's going to be a little bit tougher because we haven't gone over our logs, and so we're just gonna solve up to a certain point here. So I do know to find my x-intercept, that's when I let y equal 0. So I'm going to replace my y value with 0. And then I have to solve for x. I'm going to subtract 1 to the other side. Divide by -3. And then we're going to stop right here because this would involve us having to remember how do we solve with logs. And so for right now, we're just going to leave it as that. And so we're not actually going to figure out what the x-intercept is, but looking at my graph, it's somewhere between 1 and 2. And that's good. All right, and that's it.